Welcome to Ask and Learn.
Okay, so for this problem, we are given two functions, f1 and f2, that are big theta of g1 and g2 respectively, and are told that f2 is not equal to 0 for x greater than 0, and that g2 is not equal to 0 when x is greater than 0, right? And so that is going to allow us to divide without fear of division by 0. Okay, and so then what we are asked to prove, which I, of course, spelled wrong, that f1 over f2 is big theta of g1 over g2. And I have dropped the function notation, right? Just bear in mind that this would be f1 of x, f2 of x. These are functions. Okay, so given that f1 is big theta and f2 is big theta of g1 and g2 respectively, we can infer, given some constants, c1 through c4 and k1 through k4, that the absolute value of f1 must be less than or equal to some constant c times the absolute value of g1 whenever x is greater than k1, right? And this is because since it's big theta, it must be big O. Similarly, since it's big theta, it must be big omega, which means that there's some other constant, c2 times g1, that f1 would be greater than, and that will occur at some other k. We'll let that be k2. And we get the same thing for f2 and g2, right? So because f2 is big theta, it must be big O. So there's some constant c3 times the absolute value of g2. That f2 is less than or equal to. And there is another constant, c4 times the absolute value of g. That f2 must be greater than or equal to, and this would occur at some point x being greater than k4. Okay, well, when f2 does not equal 0 and g2 does not equal 0, then this inequality here is going to be the same as 1 over the absolute value of f2 being greater than or equal to 1 over c3 times the absolute value of g2. Right, and we know that they're not going to be equal to 0. It was in our assumptions here, right? We're given that, so we don't have to worry about it. And we can do the same thing here. We'll get that 1 over f2 absolute value will then become less than or equal to 1 over c4 times the absolute value of g2. Okay, so let's assume also that c3 and c4 are not 0. Okay, so we do have to add that assumption to make sure we're not dividing by 0. We're also going to take k to be the maximum of these k1 through 4s. So that way we're always guaranteed to be x is large enough as we need it to be. Okay. So we'll let x be greater than k, which is now the largest of all our k's. And then we can consider the absolute value of f1 over f2. Right, it's going to be equal to the absolute value of f1 over the absolute value of f2. which is then less than or equal to C1 times the absolute value of G1 over C4 times the absolute value of G2. Right, and that is going to be equivalent to C1 over C4 times the absolute value of G1 over G2, which is equal to some constant C1 over C4 times the absolute value of G1 over G2. So think it this way of x, if we want to add our function notation back in. Of course, on this side, the function notation would look similar. Right, so we'd have f1, f2 of x. Okay, and then we can make the same argument for our other inequalities. So if we get to the same spot here, but we also know that f1 over f2 must be greater than or equal to c2 times g1 over c3 times the absolute value of g2. All right, so this is going to be equal to c2 over c3 times the absolute value of g1 over g2. Okay, and then, of course, if we care to, we can put that back into our function notation. Should be the proper way to do it. So the function g1, g2 of x, absolute value. Okay, so then by the definition of big O notation, right, f1 over f2 of x here is greater than or equal to some constant, namely this constant c1 over c4 times the absolute value of this g1 and g2, right? So then we know that f1 over f2 is big O g1 over g2. Okay, and we also know then that this function here, this f1 over f2, must be greater than or equal to some other constant, namely c2 over c3. The same thing, so then we have that it's big omega of g1 over g2. And since it's both big O and big omega, then f1 over f2 must be big theta of g1 over g2. All right, and that would conclude the proof.